It's great to be here. I thought I would start off, before diving into the talk, with some jokes, topical jokes. So I heard Hans's keynote yesterday was great. You know, a lot of great new features coming out in Gradle. The one I'm looking forward to the most, though, is that new cryptocurrency that he's talking about, where the proof of work is Java artifacts that are built by Gradle tasks. Did you hear about that one? No? You missed it? The build cache? All right. Next joke. How many Maven developers does it take to screw in a light bulb? Not sure. I'll let you know when the dependency result finishes. All right. And final joke, an ant developer walks into a bar, and the bartender says, "What is this, a joke?" All right. Actual content. But before that, before I dive into the talk, I want to ask people here, how many of you use GitHub? Okay, so basically all of you. And you're familiar with the GitHub code browser, right? It's a nice, clean interface for exploring code, whether it's your own or code from open source libraries. Do you ever wonder, or do you ever wish when you're exploring GitHub that you could just kind of hover over things for tooltips or jump to definition? Anyone? Well, now you can. This is actually an open source free Chrome extension that is powered by Gradle underneath the hood. And so that's just kind of a teaser for the tail end of this talk so that you all are kind of wrapped in paying attention. But before I get to that, we're going to talk about Android examples. So this talk is really about how to become a better Android developer using examples and patterns from open source. And I just want to point out that these slides are online, and there will be code snippets in this slide that are linked to locations in source. So if you want to visit that link and follow along at your own leisure, you can just go there. And with that, let's dive into it. So a little bit about myself. My name is Beyang. I work at a company called Sourcegraph. And what Sourcegraph does is it's essentially a tool for understanding and reading code. So it helps you dive into code bases. And the reason I mention it is because one of the things that we do is we index a lot of open source code on Sourcegraph. So you can go to basically any GitHub repository, private or public, in the languages Java, Go, Python, TypeScript, and get kind of an interface that was similar to what I just demoed on GitHub with the jump to def and find references. And because we do that, we index a lot of open source code. And so that kind of leads nicely into the topic of this talk, which is how can you learn from code that you did not write? How can you mine all the code that's out there in open source for the knowledge that it contains and make yourself into a better developer? So I want to start off by asking folks in this room, when was the last time you had to understand a large chunk of code that you did not write? Sometime in the last week? Who had to do that? Last week? Cool. When was it? Was it during code review, perhaps? Was it diving into an open source library? Was it diving into a part of the code base that was unfamiliar to you that you had to touch? Okay, so did you enjoy that process? Yeah? Yes, no? Which do you prefer, writing code or reading code? Anyone? Crickets? All right. Well, I think it's interesting because I actually enjoy writing code a lot. It's one of the most fun activities in life for me. But reading code, on the other hand, especially during a process like code review, where I have to review a giant diff or I have to dive into an unfamiliar library, it's often frustrating and challenging. And so that's what I want to talk about in this talk, kind of a process and framework for diving into an existing piece of code and efficiently kind of grasping the concepts. And in going through that process, we're going to cover a bunch of examples from real-world open source Android code bases. And then at the tail end, I'm going to talk about how to build a tool to accelerate that process, because that process is really what we do. It's kind of our bread and butter as programmers. We're not just people who type at a keyboard. We're people who translate text on screen into these conceptual abstractions in our brains. So this talk is special, and I'm not just tooting my own horn, even though I like doing that. It's special because most other talks at this conference, and most conference talks in general, are about pieces of software or code that someone has written. They produced this code base, and they kind of understand the ins and outs of it because they were the author, and now they're kind of sharing with the rest of the world what that does. This talk, on the other hand, is going to be about code that I had absolutely nothing to do with. I was not the author. I've never committed to any of these code bases, so it's going to be a fun ride. So we're going to cover 3 code bases. Cumulatively, they total over 2,500 GitHub stars, 1,000 plus Java files, 140,000 lines of code, 10,000 commits, and again, I didn't write any of this code. So those 3 code bases map to these 3 applications. So we're going to talk about the Wikipedia Android app. How many people have used that here? Cool, a few of you. Those of you who haven't, I recommend downloading it. It's a very good app. We're going to talk about another monitor, which is kind of like the system activity monitor for your phone. And we're going to talk about AntennaPod, which is this podcasting application. And in covering these applications, we're going to cover a bunch of concepts that these applications use from the Android world. So everything from kind of the general model view controller flavor that Android has to specific things like using open source libraries like Butterknife or Retrofit, or hitting parts of the SDK like subclassing the Android service class. So without further ado, let's dive in. Wikipedia. So what is this application? It's a pretty straightforward tab-based application with 4 tabs, 3 of which are shown here. The first tab is, you'll probably recognize this. Anyone want to take a guess as to what kind of view that feed is? What's that? Recycler view. Great guess. That's exactly right. So it's a recycler view that has a couple of custom sub-view classes for containing different types of cards in the feed. The second tab is another recycler view that contains reading lists. It lets you create and persist reading lists for later reading. The third tab isn't shown because it's just a history view, which is pretty self-explanatory. And then the fourth tab is this map view, which shows nearby points of interest drawn from the Wikipedia API and shows them adjacent to your geolocation. All right, so that was the product overview of the app. Here's kind of the code level view of the architecture. So I've kind of split things up in terms of activities and views. I've omitted all the other classes just to keep things simple. So this is kind of the backbone of the application. The application itself is, the code base itself is quite large. It's got about 750 Java files, and I think it's around like 70 or 80,000 lines of code. So if you do like a rough translation from 80,000 lines of code to like words, 1.5 words per line of code, that comes out to roughly the size of like half the length of the novel Moby Dick. Anyone ever read that? It's a long novel. Not something that you want to read front to back if you want to understand a code base. But here I've kind of condensed it to just a dozen or so classes that form the main backbone. And so there's a main activity. That's no surprise. 99% of Android apps have a main activity. It's a single fragment activity, delegates the main fragment. And then the main fragment refers to 4 subfragments that correspond to the 4 subviews of this application. And interestingly, the main fragment goes through this enum class to refer to those 4 fragments and uses the enum to kind of dynamically construct them based on the type of view that's passed. And then on the right-hand side, you have a bunch of views that are just referred by each activity. You should see some pretty familiar things there: a recycler view, the map view, and a feed view, which is a subclass of the recycler view. And also on the right-hand side, there's kind of the rough layout of the application and how that corresponds to the view classes. So this picture is kind of, if you're a core contributor to Wikipedia, you should probably have something like this picture in the back of your mind at all times, right? Because this is kind of the big picture of the code base, and whatever tiny part you're working on, you want to understand how it fits into this big picture. And if you're new to this code base, if you're coming to it for the first time, this is probably something that you want to get to relatively soon. Otherwise, who knows, you might go down some rabbit hole and not really understand the context for the work that you're doing. So how do you get to this picture? How do you go from 0, which is I'm staring at the README, to a full conceptual picture? In other words, how do we discover the backbone? So if you just ask the question, how do we discover the backbone, that's a very big, scary question. And if you try to answer it directly, you'll probably answer with something vague or just kind of half-baked, or you'll get lost in the code and you're not really sure how to continue. So a good trick that I like to apply is when I'm trying to discover the backbone of the application, I just ask, what does it do on initialization? How does it arrive at the initial state that the user sees? And it's a very different question because it forces you to focus on a specific part of the application and trace the flow of data from there. But in doing so, I'd like to show you how that kind of leads you through all the main classes in the application. So with Wikipedia, this is the initial state of the application. The first time you open it, you see this view. So you got the tab bar below with 4 tabs, and then the feed at the top. So how do we get there? So where do we start when we talk about initialization? Well, you look for the quote-unquote main function, or a main method. And in Android, there's really only 1 or 2 methods that could be that. Every Android application has a main activity, and the activity class initializes with this onCreate method. So if you're in your IDE or in some web-based code browser like Sourcegraph, you can just do a simple search for main activity, jump to that class, and with Wikipedia, it leads you to a code snippet. And if you're following along on your own laptop, I do want to point out that all these things are linked directly into source. So if you want to go source diving and zone me out, that's perfectly fine. But with Wikipedia, if I do a symbol search, here I'll notice that there's no onCreate method in the main activity class. So what does that mean? It means that the onCreate method must be defined in some sort of one of its superclasses, right? So I'll just walk up the inheritance hierarchy here. And so this class that inherits from single fragment toolbar activity has an onCreate method. What does it do? It invokes its superclass method, and then it appears to do some initialization for the action bar. So that doesn't tell me a whole lot. So I'm going to go and jump to the method on its superclass to see what that does. And here you'll see that it invokes its superclass method, sets a content view, and then this is interesting. It adds a fragment from this method createFragment. So if I jump to that, I'll find that it's actually an abstract method to find this class. So how do I get there? Well, it must be implemented by some subclass. So I'll do kind of a symbol search for it, and then I'll jump to main activity because I was just there, and I'll see that it calls this mainFragment.newInstance method. So that corresponds to that code snippet in the slides. And so now that I'm here, I'm like, okay, so I'm asking, what does it do on initialization? How do I arrive at the initial state? I get to this main fragment class. It seems like it's doing most of the work. And so now let me jump to that class and ask how that initializes. So it's a fragment, so the initializer method is going to be onCreateView. And what is this doing? So in onCreateView, the first thing that you'll notice is that, can everyone see this, by the way? Anyone? All right, cool. The first thing it does is invokes this butterknife.bind method. So that's kind of interest because if you're kind of new to Android development, this is an interesting third-party library that you can use to bind views to fields in activity and fragment classes. Is anyone not familiar with butterknife here? Okay, so if you're not familiar with butterknife, you probably find, when you do this wiring up in activities and fragments, you probably call find view by ID a lot to set those fields. And what butterknife lets you do is it basically adds a lot of nice syntactic sugar around this binding, so you only have to declare this annotation on the view fields, and then in the initializer, you just invoke butterknife.bind and it does all the wiring up for you. Second thing it does is it adds more wiring logic. So it adds an adapter to the view pager, and it adds a listener to the tab layout field. So view pager and tab layout, those seem like the two things that might correspond to the things that we see on the screen, right? These two things. And that's indeed what they correspond to. And this is the logic that adds the listener to the tab view, so the tab layout. And when a person taps on the correct item, it changes the thing shown in the view pager. So we're still not done yet because we still haven't answered the question of where those tabs come from. So let's hop back to main fragment and look at its initializer again to see what else it's doing. Another thing it does is it inflates the view from some XML. And if we jump to that XML, again, this is just using your basic jump to def functionality. We get to this snippet where it references this Nav Tab layout, and that refers to a class in this repository that subclasses bottom navigation view. And that's something that most people should be familiar with here, right? It's kind of a standard Android SDK class for specifying a view from the bottom. And we see there that it iterates over this enum array defined in Nav Tab, and then adds each item in the enum to the menu. So there's a lot of source code, I know. We're getting a little bit in the weeds here. But we're almost done, so stay with me. We jump to the Nav Tab Enum, and this is kind of interesting because it's an enum class, but with a logic embedded in it. So this is a pattern that we'll see a lot in this application, actually, which is using an enum class to do essentially dynamic polymorphic construction. So when you have a thing of a certain type, but there's multiple subtypes, and you need to create an instance of that, but the type of that is determined at runtime, this repository likes to handle that using an enum class that embeds references to the constructors of each of those subtypes. So you'll notice that in this case, nav tab refers to the type of tab. And there's 4 options: explore, reading lists, history, and nearby. And those map directly onto the 4 tabs in the application. And they each invoke the constructor of the corresponding fragment for that application. And that leads us back to this picture. You'll notice that we covered all the main activities in the backbone. And if you just look at the definition of each of those activities and fragments, you'll see references to the views. So in answering this kind of simple question of how do we arrive at the initial state of the application, we've gone through enough logic and information to arrive at this picture, which is kind of the big picture that you want to have in mind when diving into this code base. So obviously, it's not just enough to have a high-level overview of an application. We also want to dive into specifically how various features work, right? So let's zoom in on the feed fragment. That's the fragment that maps to the news feed, the explore feed that you first see. This is the architecture of the feed fragment. So just quickly, the feed fragment is kind of the center of all activity. It also holds a reference to this feed adapter, which provides views to that recycler view. The feed adapter, in turn, creates instances of the subviews. So you have a view for each type of card displayed in the feed. It also goes through an enum class, similar to Nav Tab, which you'll see later implements essentially the same pattern as before, with an enum embedding references to constructors. And then on the model side, it has feed fragment, again, has references to Wikipedia app and feed coordinator classes, which then hit the Wikipedia API. They make API calls to this REST API. And so again, the question is, if you're working in the feed, this is probably the picture that you want to arrive at some point. This is the conceptual model you want to have in your head. How do we get there? Well, let's essentially ask the same question. So how does the feed work? That's kind of vague. Instead, let's ask, how does the feed initialize? So if you go to feed fragment and look at what's going on in the initializer method, one of the first things we'll notice, first thing we'll notice the use of butter knife again to eliminate boilerplate in wiring up view and controller logic. And then the next thing it does is it initializes the feed adapter and passes it to the feed view. And the feed view, you probably guessed, is the view that actually displays the feed. And so now we're going to apply kind of like a question-answer process. So after after we get to this point, we're like, okay, how does it initialize? How does it get to the feed view? Now the next natural question is, where does the feed view get its cards? So we look at the initializer method, and we see that feed view subclass is recycler view. We know what that is. And you'll note from before that I pointed out that the feed view gets an adapter passed to it. And so the adapter, as is typical with recycler view patterns, provides the content for the cards. And so people familiar with Android development will be familiar with the onCreate view holder and onBind view holder methods of recycler view adapters. They essentially create the subclasses to pass to recycler view and also rebind the data displayed in the recycler view when that subview is recycled. And so what is this doing? Well, the onCreate view holder method, which creates new instances of those subviews, those cards, references this card type class. And if we jump there, we'll see that it's another instance of, it's another enum class. It's very similar to the Nav Tab class, and it references a bunch of constructors. And so now we're not done yet, because now we've answered the question of, where does the feed get its views, but there's also the other side, which is, where does the data come from to populate these views? What's kind of the model side of the model view controller pattern? So we jump back to feed adapter, and we go back to that onBind view holder method, because that's where the subview actually gets bound to new data. And we try to figure out, what data is actually bound to that subview. And one of the things it invokes is this setCard method. So that seems like it's setting some sort of model class. And you'll notice that it refers to, it's setting the card, passing it the variable item. And it gets the item by invoking this item method down here. And this is all just, if you're following along in an editor or in that web-based view, you're just jumping to def. Item refers to this field items in this superclass. And how does that field items get initialized? In the subclass constructor. And it does so by passing the value of coordinator.getCards. Coordinator is an instance of this thing called feed coordinator base. So let's jump there. So what does feed coordinator base do? It has a reference to this client request callback instance. And if we jump to client request callback, we'll see that essentially callback, it does some work to fetch the cards, and on success, it invokes append card on the feed coordinator base class. So what it looks like it's doing is it's doing some work to fetch the data and then adding the data to some in-memory data structure. And so if we dig a little deeper into this class, we'll see that it's adding a bunch of clients that handle the callbacks. And if we drill down into one of those clients, we see that in the request method, it's creating an instance of a class called retrofit, and then using that to invoke the API request. And quick straw poll, how many people here are familiar with retrofit? How many people are not? Okay, so one or two of you are not. So retrofit is an extremely popular Android open source library. It's what essentially does is it maps a REST API to a Java interface, and it's kind of viewed as the best practice way of hitting a RESTful API. So if you're trying to go through and learn from example with Android, this essentially gives you an example of how to use retrofit that you can use as a starting point. So to recap, things of note that we noticed along the way in kind of tracing the logic of the feed view, the use of Butterknife, again, to reduce boilerplate, the use of retrofit to make RESTful API requests, and then the enum pattern for dynamic polymorphic construction of different subclass instances. So now I want to take a step back. We've gone through just kind of like a whirlwind tour of code snippets, and you've probably gotten lost because it's very hard to trace through code on the fly. But I want to talk through kind of the general algorithm that we're applying here in tracing this logic. Because if you're doing this, at home or on the weekend or during the working day, you're doing this because you want to quickly understand the concepts in the code. So what are we doing here? All we're doing is asking a question, a specific question about the code, finding the answer, and then asking another question based on the answer, right? And that's a brain-dead simple approach. It's not really anything special, but the mnemonic I like to, or the main point here is you should always be answering a question. A, B, C, always be questioning. And the reason for that is because the question, if you don't have a question in mind, you're not really being focused in your reading and understanding the code. And that's an important thing because when you're writing code, you're always focused on doing what you're doing, right? So that's a naturally focused activity. But when you're source diving, when you're diving into a new code base, you often get unfocused or lost. You lose your place because you don't have that focal point. You don't have something to make you, focus on a single point in the code. And a question is often the thing you need to stay on track. So that's a Wikipedia feed. We covered kind of the data flow through the view side all the way to when it makes a request to the Wikipedia API. And now let's move on to the next app. So the next app is another monitor. So how many people have heard of this or used it before? Anyone? Not a lot of you. OK, so it's a pretty cool app. It's essentially a system monitor for your phone. So it displays a kind of live graph of CPU and memory usage on your phone and does so also on kind of a per application basis. So you can see which applications on your phone are consuming up all the resources. And here's the backbone for this application. So it's a much smaller app. It's quite simple. There's only one activity class that has a bunch of references to various buttons and labels in the main view. And the two things I want to cover here, well, really three things I think are interesting to point out. One is there's a custom view defined by the view graphic class, which corresponds to that chart that's highlighted in green. That's kind of like a live update of the stats. And it's actually kind of interesting how that's implemented in this code base. The second thing is the use of a service reader, which is a subclass of an Android service. And for experienced Android developers, you'll recognize the service class as the thing that you use anytime you want to do some long-running background task. So it's got one of those. And the third thing that's interesting is it also uses concurrency. It has background threads. And what's particularly interesting is it not only has a background thread for the service reader, but also uses a background thread to render the view, which is odd. So let's dive in and see what we can learn from this code. So again, the answer that we start with is, how does it arrive at its initial state? So we go to activity main, the main activity class, and we look at its onCreate method and see what it does. So one of the things it does is it starts this service class. And that's an instance of this service reader thing. And yeah, that's of interest. And another thing it does is it initializes this view. So notice that it doesn't use butter knife, so it has to call find view by ID, and it sets a field on the activity. So based on that, we can go one of two directions. We can either look at what it does on the back end or what it does on the view. Let's do the view first. So we jump to view graphic, which is just the type of that field. And we see that it extends a texture view. How many people here know what a texture view is? OK, so far fewer of you. So texture view is this class in the Android SDK that's typically used for like 3D rendering or video playback. So it's kind of like the Android equivalent of like HTML5 canvas. It's kind of low level. You can do custom drawings, and it updates really quickly, and it gives you kind of full power and control. And some trivia about the texture view. I think it's one of two view classes in the Android SDK that can actually be rendered in a background thread. And it offers that capability because it's typically used for high performance use cases. And here in the subclass, we see things that look like they correspond to CPU stats. CPU total, CPU AM. And if we jump to the drawing class of this text review subclass, we can see, yes, it indeed does draw things that look like they correspond to the chart that we saw in the UI. And what's interesting here is that two things. Well, one, the rendering happens in the background in this kind of ongoing runnable task that runs in a background thread. And the second thing to note is that this runnable is actually created in a separate class. It actually lives in the main activity class, which is kind of interesting. It's probably an anti-pattern. Code base is a little messy, but it's worth noting. And inside the runnable, you can see the invocation to this method, the drawing method. And so we can kind of surmise that the way that this thing draws the chart is that it just has this thread that is on a time sleep loop that just reads the latest stats and updates the charts every, whatever the timeout is. Okay, so that's the view side. What about the what about the data side, the model side, the back end? So anyone here know how you can read CPU and memory stats from the Android kind of standard API? Anyone? Anyone want to take a guess? All right, no brave souls. All right, so let's dive into this. So it sets these stats on this text label. So let's jump to the def of the service reader to see where it's getting those stats from. Inside service reader, there's another runnable that runs in a loop with a sleep interval, and it basically does only one thing. It invokes this read method, and inside the read method, we see it's reading from the file system. So it just creates a new file reader and reads from /proc/meminfo for memory stats and /proc/stat for CPU stats. So there's no magic here. Android is just Linux, it turns out, and so it's just reading from the file system and parsing those statistics. That's kind of interesting. So that's pretty much for another monitor. That's not just the backbone, that's kind of like the whole app. Let's move on. So third and final app is the podcasting app. So this is a very rich application. It's probably the largest application covered in this talk. It's an app for playing podcasts. So it's got a bunch of different types of views for displaying album art. It's got that left drawer that pops out. It's got a playback view. It's got a sticky view at the bottom if you're currently playing something that follows you around the application. And since we've already done two of these, and I don't want to get too repetitive, I'm just going to go through this pretty quickly. So here's kind of the AntennaPod backbone with the activities and views laid out. So similar to the Wikipedia app, there's kind of a couple main sub-fragments that handle the different views of the application with a main activity tying them together. And it's a nav drawer-based application, which means the navigation in the application happens with that left drawer pop-out. And so again, the question is, how do we arrive at this backbone? What does it do on init? Main activity.onCreate, it's wiring up a bunch of views. It's calling findView by ID to get references to the views. It's not using Butterknife, so it has to do that. It passes them to this thing called Fragment Manager, which is a thing that I won't get into, but it's something that you might want to dive into if you're learning from this code base. And it also initializes this drawer layout class, which corresponds to a class in the SDK that corresponds to that left-hand side drawer pop-out. And it also initializes this external player fragment, which corresponds to the view that shows the persistent playback at the bottom. So I'm not going to dive into any of that because I think by now you get the point. We have this kind of like question-answer process that starts with, how do we arrive at the initial state of the application? And so I leave it as an exercise for the listener to answer the following question. How are audio files fetched and stored in this application? So it's a podcasting application. We have to assume that it has some way of kind of efficiently managing downloads, potentially many downloads in parallel, and storing them in some place on disk. And then if you want a hint, here's a couple places in the code that you can start. So this concludes the code snippet portion of the talk. So if you've zoned out for that and gotten lost, you can now pay attention again. But we'll go back to the earlier point I made, which is, open source is really this treasure trove of knowledge. You have not just libraries, but entire applications written in the Android ecosystem that are completely open source. And you're probably accustomed to using open source libraries as a dependency in your own applications, which is great. They're extremely valuable for that. But they're also extremely valuable for learning new patterns and seeing how other people write applications. So at this point in the talk, we've kind of covered two things. Are you guys familiar with the old adage, if you give someone a fish, they'll eat for a day. If you teach someone to fish, they'll eat for a lifetime? Okay, so far, we've seen a lot of fish. We've seen a lot of code snippets. And we also talked a little bit about, a general process for, coming up with more of those code snippets when you're diving into code yourself. But I think as self-respecting developers, the next thing we really have to ask is, how do I build a better fishing rod? Because we as developers are tool builders, and so once we learn how to do something, I think the logical next question is, well, how do I make a tool that lets me do it faster? And since this is Gradle Summit, we're going to build a better fishing rod for exploring code with Gradle. So taking a step back, if we actually think about what we're doing when we're diving into a code base and trying to understand the concepts, we're trying to understand the structure of code. What is the structure of code exactly? What is kind of the thing that we're building in our head? And kind of obvious from the architecture pictures from earlier, what we're essentially doing is building this graph. Code is just a graph. The nodes are symbols. So every different kind of symbol, whether it's a class definition or a method definition or a package, that's a node in the graph. And the edges are just references. So anywhere you can reference those names, those are the edges. And when we're building this conceptual understanding, what we're doing is walking this graph. So we start at a particular node. So in the examples that I showed, we start with the quote-unquote main method. And then we kind of do this forward-backward traversal of the graph, jumping to def, finding references until we have kind of a clear picture of how things are linked together. And so if we want to build a better tool for understanding code, we should make it easy to walk that graph. So this is exactly what IDEs do. They offer primitive capabilities like jump to def, find refs, symbol search, text search as kind of a fallback, that make it easy to walk that graph. And that's why we use them every single day, every single hour, every single minute of writing code. One thing that some editors do better than others is this kind of setup task. So in order to get to the good stuff, which is jump to def, find ref, symbol search, text search, sometimes you have to set up an editor to do that. You have to install a plugin or set some configuration file properly. And it's a little bit annoying. You'll do it for the code that you work on every single day. But what about the random open source repository that you think looks cool, but you don't necessarily work on? And so there's nothing wrong with IDEs. They're great tools. There's so much technology built into them. And I don't really know how we get as much work as we get done today without them. But just think about all the other places that you interact with code in 2017. It's not just inside your editor. It could be in an online code browser. Maybe your company has something that lets you view the entire code base, not just the stuff that you have checked out on your local machine. Maybe it's on Stack Overflow, where you're looking at a code snippet. Maybe it's in some blog post that's teaching you how to do something in Android or some other framework. Maybe it's a snippet that someone has sent you in Slack or some other chat application. Or maybe it's during code review. Every single day we have to read and understand code that was written by someone else in an interface that often doesn't offer the same kind of primitive capabilities for understanding code as we're accustomed to in the IDE. So the question is, how can we bring the brains of an IDE to all of these other different places? And how does Gradle fit into that picture? So if we look at the general architecture of an IDE, it kind of looks like this. And this is a gross oversimplification. But on the front end, you have kind of the IDE UI and also the plugins that plug into it. And then there's typically some sort of API for interacting with things on the back end of the IDE. And part of that back end are language modules, semantic analyzers that invoke build systems and compilers and extract those symbols and definitions and references and make them available to the front end. And so we want to generalize this picture, not just to editors, but to all those other places that you view code. Maybe the picture looks something like this. So on the front end, you have all these different UIs where you're looking at code as a human. And on the back end, you have language modules that reference various things like Java-C and Gradle. And in the middle, you need some sort of protocol that kind of standardizes the way that the UI components can access the back end, because you don't want to reinvent the wheel every time you want to add kind of intelligent navigation capabilities to a new place to view code. And so this actually exists. This is what we built at Sourcegraph, and we're in the process of open sourcing a lot of this. The Java language server is not open source yet, but we're working on it. It should be out hopefully in the next month or two. And the gray thing in the middle, the protocol, is actually an open standard. It's called the Language Server Protocol. And it's this new protocol that's gaining a lot of traction and is starting to be used by a lot of editors, the first one being VS Code, for defining a standard interface for defining intelligent navigation capabilities in your editor. So basically, the protocol defines a bunch of endpoints that do jump to def, find references, simple search. And so the idea is you build a language module that serves things according to the protocol, and someone else builds a UI that speaks to that protocol. And if they both speak the same protocol, you can just hook the two up together. And so you only have to build one language module, and you only have to build one UI, and you can hook them together instead of building a new language module for every single code understanding UI you want to explore. And a thing to note here is that Gradle is an integral part of doing this, because in order to extract the definitions and references, we essentially have to compile the code. Compile it like halfway until we have the types and the AST and all that. And in order to do that, we have to build it properly. And if we want to do it really well, which is let you not just jump within a local code base, but also jump to all those dependencies in open source and elsewhere inside your company that you use, we have to understand the dependency graph, which is what's defined in Gradle. So I want to pause here and give a quick shout out to Aaron Leung, who's sitting in the back over there, because Aaron is actually the author of our Java language server. I actually did very little of the work. I just wrote the part that has to do with Gradle. But he's kind of this semantic code analysis engineer extraordinaire. And if you have questions about how we do Java analysis later, you should go find him out. That's what he looks like. And that's his Twitter handle. So going back to Gradle. So as I mentioned before, Gradle is an integral part of this because Gradle is what defines the dependency structure of code bases. And so if we want to do cool stuff like, hey, you're referencing some class or method defined in this open source repository, and you just have to click on it to jump to where it's defined, we have to understand Gradle. And understanding Gradle from the point of a code understanding tools builder is actually harder than it might seem at first. And the problem essentially reduces to this. It's that Gradle looks declarative. If you look at it, it looks like annotated JSON, pretty straightforward. But it's often not, right? So in Gradle, when you define your dependencies, you can pass it the values of arbitrary variables. And who knows how those values get initialized or set or modified over the course of the execution of the script. Even things like artifact names. If you're publishing an artifact to Maven Central or another repository, those can be defined anywhere in the script. And you also have all these plugins which do amazing things, but they can also have side effects, and it's very hard to reason about those side effects. And so what this means is that really to be 100% sure about what the dependency structure is in a Gradle project, you essentially have to run the Gradle script. And in some settings, that's okay. At Sourcegraph in particular, when we have a client that's running our code browser on premises, we can just execute the script because it's trusted, right? We have a plugin that just dumps the metadata out in this easy-to-read form. But if we're trying to build a cloud tool, or if you're trying to build a tool that powers code navigation on things like snippets, then you can't trust the scripts that are being passed to you, right? And so what do you do in that case? There's kind of this trade-off between doing things the easy way and just executing the script versus trying to analyze the script as a piece of data and trying to infer the structure from there. And so as kind of a side note, the way that we actually did it in our infrastructure is we essentially wrote this quasi-Gradle interpreter. It's kind of like a fake Gradle executor that simulates some of the execution, so we can extract the variable values, or at least run enough of the script so that we have those variable values defined. And hopefully that gives us enough information so that when you pass arbitrary variable values to your dependencies directive, we can figure out what those are. And so being very good at names, we named this fake Gradle interpreter Fradle. And it just kind of does a best effort job of executing Gradle without giving the script free rein to do anything it wants. And so I have a couple asks for the Gradle community, which is typically when you're thinking about building stuff for Gradle, you're focused very hard on how do I make this build faster? How do I make it easier to package things? But there's another side to tool building, which is about understanding the code, helping a human being understand the concepts in code. And remember that tool builders like myself and other people want to build tools like that are users too. And so where possible, let's try to favor strong conventions in Gradle scripts that make it easier for things to analyze what's going on in the script without having to execute them, and favor things that are more declarative instead of imperative, and avoid things with too many side effects. So that's it for this talk. I want to leave you with kind of two ideas. One is, the universe of open source is amazing. Never before in the history of humankind have we had such a large corpus of knowledge. And let's take advantage of that. Let's mine the trove of knowledge that's in open source. And secondly, as developers, as tool builders, let's think about how we can build better tools to accelerate that understanding. And that's it. Do I have time for questions? Questions? Anyone? I have socks branded with your favorite developer tools company for those who ask questions. Yes?
Does Sourcegraph work for Kotlin code?
For code what?
For Kotlin code.
For Kotlin code, not yet. But the great thing about the language server protocol is it's an open standard. And so there's language servers in development for basically every major language. And I can't remember if Kotlin is among them yet, but it's only a matter of time at this point. And then because there's that standard protocol, anything that speaks that protocol, once the language server exists, you just plug in. Do you want a sock? A pair of socks? All right. I'll get it later. I have a bad throat. Anyone else? Questions? Yes?
For the fake Gradle computer,
Yeah.
do we use any Gradle code for that, or is that still?
No, we didn't. And the reason is a combination of, I wish I could say it was because we thought through the entire problem, decided not to reuse the code, but it was really because when we developed it, it was for a particular client, and we had a deadline. And a lot of the Gradle code that we looked at, it looked like very dedicated to the purpose of evaluating the code. So we just, essentially what we did was we took a groovy AST parser and subclassed we did essentially like a post-order traversal over the tree and to simulate the execution. Yeah, but we're looking to rewrite that. It's one of the hackier parts of the code base. Do you want a pair of socks? All right. They're not very aerodynamic. All right, I got one more pair of socks. Any takers? Oh, yes, way in the back. No. All right. All right, well, thank you very much for coming to this talk, and thanks to Hans and Eric and the rest of the Gradle team for having me.